indicate that this projectile motion or this projectile question is one dimension, is that you will be told that a body is projected with a certain velocity, and the velocity is horizontal. So if you are told that the velocity of the body is given a horizontal initial velocity, it's enough to show you that the question is a one-dimensional projectile motion. A body is given an a horizontal velocity of so and so, then it means it is a one-dimensional projectile motion. In two-dimensional projectile motion, the key attribute of it is that the angle between the horizontal and the velocity of projection must be, there must be an angle, okay? So there must be an angle between the horizontal and then the velocity of projection. So two-dimensional projectile motion. Questions would not state that this is one-dimensional or two-dimensional, but you must figure out ways to identify whether this is one-dimensional or two-dimensional projectile motion. Please, can you hear me?
Yes,
Enoch.
Yes, sir. We can hear you.
All right, Enoch, your hand is up.
So please, I wanted to say you were not audible enough.
Is it better?
Yes, please.
Okay. So, example, whenever a missile is being fired or a javelin is thrown, the horizontal will be here. This is the horizontal, but the javelin must be thrown at an angle. So those of you who have actually competed in that event before, the javelin will be thrown at an angle to a horizontal. Okay, and when it is thrown at an angle, this will be the trajectory or the path will land on the ground. And this is when you get an effective throw. So in two-dimensional projectile motion, yes, there is a horizontal and there is an angle of projection theta. This is the velocity of projection u. This is the horizontal. Okay, so we want to follow the path just as we did in one dimension. But in projectile motion, you don't always forget the assumptions. Air resistance is neglected, and the other assumption is that gravity does not affect the motion of the projectile horizontally. So if it is thrown, the body is sure to move from ground to ground. This will be the path. So the projectile started from here and landed here, from ground to ground. Let's follow the projectile whilst it moves. So till it drops to the ground. Now, because the velocity of projection makes a certain angle with the horizontal, by virtue of this, the velocity will be divided into two components. a horizontal component and then a vertical component due to trigonometry or theta. So by virtue of the velocity of projection, making a certain angle with the horizontal, it will be divided into a vertical component, uy, and then a horizontal component, ux. We want to resolve using trig ratio or trigonometry to determine this vertical component and then the horizontal component. Thus, the velocity of projection u becomes the hypotenuse. That's the angle of inclination. So class, how do we determine ux? Who can help? If you have the hypotenuse and the angle and you want the adjacent, which is ux, how do we determine ux? Anybody? Anyone to help? Using trigonometry, how do we determine the adjacent of this? Please, it creates a right angle triangle. Okay, this side becomes the opposite to the angle. Opposite. The opposite is what we are calling as uy, vertical component of that. And then the adjacent is ux. Yes, Enoch, how do we determine the opposite?
So please, I think it's u cos theta.
Opposite.
For the opposite will be u sin theta.
Exactly. So when you use so katwa. So when you use so is sine of the angle involved theta, which is the opposite uy divided by the hypotenuse u. Therefore, uy is u sine theta. What about the adjacent? How do we determine the adjacent, the horizontal? Anybody? Esteem, your hand was raised earlier. Okay, Bridget.
The u cos theta.
Good. So if you take cosine of the angle cos theta, you have the adjacent, which is ux, divided by the hypotenuse, which in this case is u. Therefore, ux is equal to u cos theta. Thank you, class. So by virtue of the fact that a projectile is shot at an angle to the horizontal, we have a horizontal component of this velocity of projection, u cos theta, and then a vertical component, u sin theta. We can bring it here. Our vectors are equal if they have the same direction and magnitude and are parallel to one another. That's why I brought it here. Okay. So we have the velocity of projection will be divided into this component and this component due to the fact that it is shot at an angle, theta. And note that what we have here is the same as this. It creates a right angle triangle. And so we can say that u squared is equal to ux squared plus uy squared. Or u is equal to the square root of ux squared plus uy squared. Or you can substitute the trig component. So note this as well. Okay. So That's it. The velocity of projection is divided into these two components, u sine theta and u cos theta. We want to analyze the path of the projectile. Okay, we have a horizontal component and a vertical component, just as we saw yesterday. So let's first analyze it horizontally. Horizontal analysis of the motion. Horizontally, initial horizontal velocity ux is equal to final horizontal velocity, and they are all equal to u cos theta. So here too, the horizontal velocity is constant. And what is the reason? Same reason as we saw yesterday. What accounts for the reason why the velocity horizontally is constant? Why? Can you share with me? Why is the velocity horizontally constant? Ejewa, let me hear from you. Why?
Because air resistance is neglected
One.
or avoided.
That is one. Lionel, Judah, what's the other reason?
Yeah, please. It's because air resistance and gravity are eliminated.
Good. Horizontally. Okay. The elimination of air resistance affects both vertically and horizontally, but gravity is assumed not to affect projectile motion horizontally. So there is nothing to reduce the speed of the projectile horizontally. So in that case, initial horizontal velocity is equal to the final velocity, and they are all equal to the horizontal component of this velocity of projection u cos theta. Class, house, I'm sure we are fine.
Yes, sir.
So if the velocity is constant, then if I want to calculate how much this projectile is displaced from its original position. This is its original position. This one is started from here. At time t1, it is here. So if I want to determine how much it is displaced, it is this distance. Let's assume this is x1. So OX1, T2, T3, T4, and finally T5. If I want to determine OX1, OX2, OX3, up to OX, this horizontal distance can be obtained by using distance is equal to velocity or speed times the time taken. So just as we saw yesterday, if you want OX1 is equal to the constant horizontal velocity u cos theta times the time taken to come to this point, and that is t1. If I want OX2, the same method, the constant horizontal velocity times t2, t3, t4. Now the total horizontal distance covered, which is the range. Here it is OX. OX in this case will be equal to the constant velocity u cos theta times the time of flight. Here will represent T5 by the letter capital T. So where OX is the total horizontal distance, U cos theta is a constant horizontal velocity, T is the time of flight. T is the time of flight. So we can therefore conclude that the range of a projectile is equal to U cos theta times the time of flight, capital T. Plus, is everyone okay here up to this point? I will say, is everyone okay?
Yes, sir.
All right. Yes, Ejewa.
Sir, please, I'm finding it difficult to hear what you are saying.
Really? I'm only asking if you are. Have you been following the discussion?
Yes, please.
Okay. Then I'm sure you understand everything. So the first thing to note in two-dimensional projectile motion, the range, which is the total horizontal distance traveled, is equal to U cos theta times the time of flight. And the range is defined as the total horizontal distance traveled by the projectile. Total horizontal distance traveled by the projectile. Okay. Alvin, are you here? Hello, Alvin. Okay. Manuelasian, Emanuela. Emanuelasian.
Sir,
What is the range of a projectile? What is the range of a projectile? Yes, anyone to help? Anyone to help? Anybody to help? What is the range of a projectile? Eddie, are you there?
Yes, sir.
What we mean by the range of a projectile?
The range of a projectile
Yeah.
is the velocity, the horizontal velocity times the time of flight.
So what does it mean? What does it mean by the word range? What is it?
By the word range.
Yes. What does it mean?
Range means like the bigger minus the smaller.
Oh, okay. You see, it's rapid. What does the word range in this case actually mean? What does it
Say
mean?
the distance.
So I did well listen. I said, you see, when we are following the path of the projectile, we see it moving OX1, OX2, OX3 up to OX. And then why are you there? So we are saying OX. O is the initial position of the projectile. If it is fired, it would finally land here. And the total horizontal distance traveled by the projectile, total horizontal distance traveled by the projectile is what we are calling as the range. So the range of a projectile is the total horizontal distance traveled by the projectile. Ejewa, are you okay? Then time of flight. What do we mean by time of flight? Anybody to help? Anybody to help? Okay, Rebecca, time of flight. Rebecca, go ahead.
The time of flight is the total time taken.
The total time taken, okay, by the projectile to land, okay, on the ground or on the horizontal. So here, our time of flight is T5. T5 is the time of flight. To ensure that you have well understood this, I'm going to create a question for us to answer before I continue. Sometimes students will respond, we are okay. When you probe, the understanding is a bit shaky. So a projectile is fired a projectile of, okay, let me modify it. A projectile of velocity 100 meter per second is fired at an angle of 30 degrees to the horizontal. Determine the horizontal distance covered after 2 seconds, 3 seconds. That is A. If the time of flight is 4 seconds, calculate the range of the projectile. Can we try it? So the velocity of projection is 100 meters per second. It is fired at an angle of 30 degrees to the horizontal. Determine the horizontal distance covered after 2 seconds, 3 seconds. And if the time of flight is 4 seconds, calculate the range of the projectile. Give it a trial whilst I take attendance. Okay, I'll be with you. I think we must finish by now. Yes. What did you make for the horizontal distance after 2 seconds? Of course, that's OX2. I'm making it OX2 because it is at time 2 seconds. So this will be equal to the constant horizontal velocity, which is u cos theta, and u is 100. 100 cos of theta here is 30. Times 2 seconds. The time at that position, 2 seconds. So cos 30 is 0.866. So 86.6 times 2. What is 86.6 times 2, class?
173.205.
0.3 Newton. Sorry.
Point
Meter. Okay.
Point.
Just run it out. Is that okay? Because cos 30 is 0.866. Hello. You mean
It
point
was
2?
170.205. So
So
it's supposed to be 0.2.
okay. Then the horizontal distance traveled after 3 seconds. OX3 would also be, the velocity is constant. Okay, the horizontal velocity. So still 86.6 times 3. Yes, what is 86.6 times
259.803.
259.
0.803.
Okay, 80 is okay. This is meter. Then if the time of flight is 4 seconds, calculate the range of the projectile. The range of the projectile is u cos theta times the time of flight. So the same thing. 86.6 is the constant horizontal velocity times the time of flight, which is 4 seconds. And you are good to go. I'm sure this one, everybody must get it right. So this is discussing on horizontal velocity, their displacement at any time. Note that the horizontal distance of a projectile or the range here will depend on the time because this velocity is constant. U cos theta is constant. So it means that R is directly proportional to the time of flight. It will only depend on the time taken to land. Okay. So let's discuss the acceleration. Oh, it's my screen blur, class. Is the screen blur?
No.
No, sir.
Then Lionel, it will be a
Yes.
problem. It will be a problem from your end. Can you rejoin? Okay.
Okay.
Leave and then rejoin. Let's see if that will sort the problem out. In fact, these days network hasn't been stable. I understand. So if the velocity is constant horizontally, what would you say about the acceleration of the body horizontally? How would you describe the acceleration, Francis?
It's equal to 0.
Acceleration is 0 because when velocity is constant, acceleration, of course, will be 0. All right. So this is the discussion on anything horizontal, displacement, speed, and acceleration. Let's look at the vertical. Oh, the vertical. Please mute yourself whenever you join, okay? Now, unlike one-dimensional where the initial vertical velocity is 0, here our initial vertical velocity has a value. Uy is the vertical component of this, of the velocity of projection. The vertical component, this component. So the initial vertical velocity is u sine theta. This time around, it is not 0, as we saw in one-dimensional projectile motion. So using the equations of motion, vertical motion. Now, look at the direction of this. When the projectile is fired, this time it will go up. So whenever a body is going up, the body would decelerate due to gravity. For vertical motion, it must decelerate. And this deceleration is due to gravity. Okay, class, I want somebody to... Zion, are you there? Hello, Zion. Hello, Zion. Hey, Zion. Zion is there. Nayram. Hello, Nayram.
Sir, please, the question again.
The question is that if a body is said to be decelerating, what does it mean? If a body is said to be decelerating, what does it mean? Anybody can help. If a body is said to be decelerating, what does it mean? Okay, Prince.
Sir, please, gravity is pulling the object back to the ground.
Prince, I won't mind it to some extent. Francis, if a body is said to be decelerating,
The object speed is reducing with
the
respect to
object
time.
speed is reducing with respect to time. So, Prince, when a ball is shot to go up, no matter how hard you think you can kick the ball, if you like, go for Metro Men, just tie their legs together so they hit one ball. It would, no matter how hard they hit, it will finally come down. This is because as the body goes up, its speed decreases. So the speed will decrease and it will come to a point where the speed is decreased to 0. So as the ball speed decreases with time as it goes up, that is what we term as deceleration. So deceleration is the rate at which the speed or velocity of a body decreases with respect to time. All right. Friends, are you okay?
Yes, sir.
So because over here, when the object is short, it is going up, it will decelerate, meaning its speed must decrease. So if you want the speed at T1, T2, T3, we must use V is equal to Uy plus or minus JT. Class, must this be plus or minus? I'm deliberately leaving plus or minus. But the question is, which of these two operators would would work here when the body is going up? Yes. Must it be minus or plus? Give me
Plus.
response. Give me response from your homes. What? What
Plus.
must it be?
Plus.
Plus.
Yes.
Minus.
Minus.
Separate
Abia,
minus.
Abia,
Minus.
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 Plus
Okay.
Minus.
plus
Okay.
minus.
Hey, we say plus minus. Okay. So let me judge it. You see, the body is going up. If the body is going up, I said it would decelerate. But the question is, what is causing the deceleration? What is responsible for the deceleration of the body?
Gravity.
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 And deceleration is a negative value. So minus GT. Then when it gets to the maximum height and it is falling, we see a plus. Okay, so when it is going up, look at the direction. It is going up. When it is going up, it will be negative. When it is falling, because when it is falling, its speed would increase, then it changes to plus. Okay, so the velocity at any given time t would be equal to uy is u sine theta minus gt. This is the equation which would help us calculate the velocity of the body at any given time t. So class, the same question as I gave you. Help me calculate the velocity of the body at time after 1 second. After 2 seconds. Yes. What will be the velocity of the body after 1 second and after 2 seconds? The same questions as we saw earlier. So u is still 100, theta is 30. What will be the velocity after 1 second, then after 2 seconds? Francis?
I think 40 meters per second, then 30 meters per second.
All right, we shall see. We shall see, okay? Yes, anyone?
So after 2 seconds is 30 meters per second.
What's the
I've
velocity?
done only 2 seconds.
Okay, let's see. So after 2 seconds, velocity after 2 seconds, we'll have 100 sine 30 minus, gravity is still 10. 10 times 1. Sine 30 is half. So we have 100 times half, 50. So this will give us 40 meters per second. And after 2 seconds, we are saying as the body goes up, it must decelerate. So our expectation is that the velocity must decrease with time. So Vs, the same 50 as u sine theta is constant, minus 10 times 2. We have 50 minus 20, which is 30 meters per second. Class, is the object decelerating? Per our data, is the object decelerating?
Yes.
Yes, sir.
All right. So this is the equation which would help us determine the velocity after any time t. We can also do that using v squared. When we use v squared is equal to uy squared minus 2gh. We'll come to h. We can also use this to determine it. Okay. All right. Now, as the object moves on, it is displaced horizontally and it is also displaced vertically. So when it gets to this point, this is its vertical displacement from its original position O, H1. When it gets to this point, it is displaced vertically by this margin, H2. Over here, it is displaced horizontally, vertically by H3. We want an expression which will help us determine this vertical displacement after any time t. And class, we can do that using h is equal to ut minus half gt squared. H is any vertical height. U is the initial vertical velocity, which is u sine theta times the time minus half gt squared. So this is also an equation which would help us calculate any vertical displacement at any time t. Meaning when the object is here, when the projectile is here and want to determine the vertical height, h1 will be equal to the constant u sine theta times the time taken to come here, t1, minus half j t1 squared. h2 u sine theta times t2 minus half j t2 squared. Class, are we okay?
Yes, sir.
Then the same question. I want you to help me calculate the vertical height traveled by the projectile after 1 second, 2 seconds, and 3 seconds. The same question. Theta is still 30. Velocity of projection is 100. Help me determine the vertical height traveled after 1 second, 2 seconds, and 3 seconds.
So repeat the question again.
I want you to help me determine the vertical height traveled by the projectile after 1 second, 2 seconds, and 3 seconds. The vertical height traveled by the projectile after 1 second, 2 seconds, and 3 seconds. The vertical height traveled by the projectile after 1 second, 2 seconds, and 3 seconds. 1 minute more. 1 minute more. The vertical height traveled or vertical displacement of the projectile after 1 second, 2 seconds, and 3 seconds.
Recording in progress.
Next week, we'll start with vectors. You must know vectors before you go to. Okay, so let's look at it. So how, as we discuss it, you mark whatever you are doing. So equation to help determine vertical height at any time t, s h is equal to u sine theta. I can even decide to calculate this. I know u sine theta t minus half j t squared. But because u sine theta is constant, I can calculate the value of this and put it somewhere. So 100 sine of 30. So I know this is 50 meter per second. So I can still write h as uyt minus half j t squared. My uy is 50. So 50 times at 1 second. So t is 1 minus half times 10 times 1 squared is the same thing. 1 squared is 1. So this is 5. So it means that at 1 second, the body will travel vertically by 50, 50, that's 5. So 45 meter. How many of you got this? 45. Show by hand. Okay. Okay, so clap for yourselves wherever you find yourself. Clap for yourself if you got it right. You are not clapping. Okay. Ranka, you are clapping. Okay. Impressive. So at 2 seconds. Okay. Hey, I am seeing a lot of hands. Oh, okay. Good one. That's okay. Let's continue. After 2 seconds, it will still be 50. Okay, 50 times 2 minus half times 10 times 2 squared. 2 squared is 4. So this time around, we'll have 100 minus 20. And that will be 80 meter. How many of you got this correct? Okay. That's great. So the trick is, okay, is there. The trick is there. This is how to calculate.
Please, we can't hear you.
Oh, hello. Is it better? Can you hear me?
Yes,
Yes.
please.
Sometimes when there is a need for me to write on the board, it would go down a little bit. So let's manage. So that's it. So we've discussed the velocity. As the body goes up, it will decelerate. When it is dropping, it would accelerate. But note something. You see, let me clean my diagram and then show you. From ground to ground, the body is projected. In the meantime, your hand is still up. Is that a question?
Sir,
Hello.
please, what if I said, sir, you see the equation that you have circled, the
Yes.
H is equal to U sine theta.
U sine theta t minus half
Yes.
gt squared. Yes.
What if you use that one to find the height?
Oh, that's what I'm
Like
talking
straight,
about. That's what I'm talking
like you use
vertical.
to
I'm
find it
listening.
straightforward. And so, sir, can you use that one?
Oh, a vertical height travel. That's what I'm saying. A vertical
Okay,
height
sir.
or vertical displacement traveled by the body. That's what I'm saying. Okay. Now, note that when the body gets to this point, this is the maximum height it could go. So when you shoot a javelin, or yes, you shoot a javelin, it will go up like this, get to a maximum height, and begin to drop. So over here, this is the maximum height it could go. H maximum. Okay. Now, when it is here, this height is the same as when it is here, same height. So H here will be the same as H here. Equally, velocity at this point would also be the same as the velocity here. Okay. This shape is a parabolic shape. So we say that the trajectory of a projectile is parabolic. The trajectory is the path, its path. The path you go through is parabolic, meaning when it is from ground to ground, it creates a parabolic shape. Height here will be the same as height here. Velocity here will be the same as velocity here. Here the body is going up, here it is falling down. The velocity at these 2 points, the same. Note. The velocity of projection, when it is few seconds to drop, it would also be falling with that same velocity. So if the velocity of projection is 100, just as the projectile drops, it will also be falling with a velocity of 100. So note that. Now, at the maximum height, at this height, before I talk about that, note that for projectile motion, at every time we have two different velocities acting on the body. We have the constant horizontal velocity, u cos theta, and then vertical time dependent velocity. similar to what we saw in one dimension. So at every point, the horizontal velocity u cos theta is constant. Is constant. The vertical velocity is not constant. It is time dependent. Okay. Now, when the body gets to the maximum height, the vertical velocity reduces to 0. At the maximum height, only the horizontal velocity acts on the body. Class, what did I say? Class, what did I say? I want you people to repeat what I said.
Please come again.
I want to, okay, listen. At the maximum height, at every point, let me talk about this before. At every point, there are two velocities acting on the body. When the body is moving, we have the vertical velocity, which is time dependent, and the constant horizontal velocity, which does not change. Now, when it gets to the maximum height, the vertical velocity goes to 0. Only the horizontal velocity acts on the body. Okay, so let me give you that as an information. At the maximum height, the vertical velocity is 0. The horizontal velocity is constant at all positions. So at all positions. So in between, there are two velocities. A constant horizontal velocity, u cos theta, and vertical velocity, which depends on time. And when the body reaches the maximum height, only u cos theta survives. The vertical velocity reduces to 0. Class, why does the vertical velocity reduces to 0 at the maximum height? Anybody to help? Why does the vertical velocity reduces to 0 at the maximum height? Farida.
Say.
This question is for you.
Okay.
Why does the vertical velocity reduces to 0 at the maximum height?
Say because when it reaches the maximum height, it be
Right now, can you hear you?
say the projectile becomes stationary for some time.
Why?
Because it's be going on a constant velocity.
Why? Okay, somebody wants to help. Viveka, go ahead.
Sir, please, because the projectile is shot horizontally.
No, here the projectile is shot, horizontally, at an angle. Two-dimensional projectile motion. But as the projectile is going up, when it gets to the maximum height, the vertical velocity will be reduced to 0. Why?
Sir, because of gravity.
Because of gravity. Don't forget, gravity does not affect the body or the projectile horizontally. It only affects it vertically. So it will be reduced, the vertical velocity will be reduced to 0 because of gravity. Okay. So once I ask you questions, if you also have questions, ask. Else mine will be asked. Okay. So let's, at the maximum height, the vertical velocity is 0. The horizontal velocity is constant at all positions. So sometimes in OBG, what is the velocity of the projectile at the maximum height? Okay, so the same question, the same set of questions you answered. I want you to calculate and tell me the velocity of the projectile at the maximum height. 1 minute. It's 2:42. Calculate the velocity of the projectile. How way to calculate the velocity of the projectile at the maximum height? Maria, are you there? Maria. Hey.
Yes, sir.
And you are quiet. Jedida. He's also not here. What is the velocity of the projectile at the maximum height? Yes. Maria, what's your answer? Francis, what's your answer? Francis is gone. Prince. Hey, no one is talking. Pascaline. Bridget. Class, can you hear me?
Yes, please.
Francis, what's your answer?
Yeah, for the horizontal to be 100 meters per second, and for the vertical to be 0.
So, Francis, what is the velocity of the body at the maximum height?
The velocity of the body at the maximum height horizontally would be the same, so 100 meters per second. Then vertically 0.
Francis, what is the velocity of the body at the maximum height?
0.
No. 86.6. Do you understand why?
No, sir.
It is because at the maximum height, it only has the horizontal component. The vertical component is 0. So what it has is the horizontal component. 86.6. 100 times cos 30, isn't it?
Yes, sir.
That's it. So when the body gets to the maximum height, the vertical velocity goes to 0. Only the horizontal velocity act on the body class. Take note of that. Farida, are you okay?
Yes, please.
Bridget, are you okay? Prince,
Yes, please.
Lionel,
Yeah, please, can you say it again?
Yes, sir.
when at the maximum height, the vertical velocity goes to 0. Only the horizontal velocity acts on the body. So the velocity of the body at the maximum height is simply u cos theta. Lionel.
Sir, please. I got disconnected when you were solving the question, so I don't understand what you are saying.
So if this is the maximum height, all that we are saying is that when it gets to this point, H max, the vertical, it is similar to when an object is thrown to go up. When the object gets to the maximum height, the final velocity at the maximum height is 0. Equally, under projectile motion, when the body gets to the maximum height, vertical velocity is 0. Only the horizontal velocity, acts on the body. So the velocity of the body at the maximum height is u cos theta. That's what I said. And so if it's u cos theta and u is 100, 100 times cos of 30. Cos 30 is 0.866 approximately. So 100 times 0.866, 86.6. All right. So we are still at the maximum height. If at the maximum height, the vertical velocity is 0, then using V is equal to u sine theta minus gt, we can use this to find t. Hello, Mamia. Is it better?
Yes, please.
Okay. So if at the maximum height, V is 0, then when you equate 0 for this, you have 0 is equal to u sine theta minus gt. Bridget, help me make t the subject from this equation.
Say u sine theta over g.
U sine theta over g plus this is the short equation which will help you calculate time taken to reach the maximum height. So therefore, time taken to reach the maximum height is equal to u sine theta over g. So the same question given earlier. Help me calculate the time taken to reach the maximum height. If the velocity of projection is 100.
5 seconds.
Pardon?
5 seconds.
So
5
you mean
seconds.
5 seconds.
Is it 5? I'll solve it and see you. So
Okay.
the time it would take the projectile to reach the maximum height. So let's see, u is 100. Sine 30 divided by 10. Sine 30 is half. So 10 times half would be 5. Thank you. So it means it will take the projectile 5 seconds to reach the maximum height. So at 1 second, it is not there yet. 2 seconds is not there yet. 3, at 5 seconds, then the body will reach this point. A point where the vertical velocity is 0. Is there any question? No question. Then let's look at the maximum equation for the maximum height. Before I talk about, look at something. From ground to ground, it is projected from the ground and drops to the ground. If it takes 5 seconds to reach this point, if it takes this 5 seconds to reach this point, what will be the time taken to drop to the ground? If it's taking the projector 5 seconds to move from the ground to the maximum height, what time will it take it to move from the maximum height back to the ground? Hello?
5 seconds.
5.
5 seconds. Because ground to the maximum height, so this is the same distance. Okay, so it would take it 5 seconds to also move from the maximum height to the ground. What will be the time of flight here? What will be the time of flight?
10 seconds.
10 seconds. Oh. So if t is the time taken to reach the maximum height, then we can also say that the time of flight, capital T, the time of flight, capital T, is equal to 2 times small t. Small t is the time taken to reach the maximum height. Then we can also say that the time of flight is 2 times u sine theta over g. For ground to ground, when the projectile is shot from the ground and drops on the ground, then we can say the time of flight is twice the time taken to reach the maximum height. See, we have a simple equation for this. Okay. Remember earlier, we also said that the range is equal to u cos theta times the time of flight. We can modify this equation or what looks like formula and write it as u cos theta times 2u sine theta over g. The formula is not important. What is important is the understanding. Class, is everybody okay? Friends,
Okay.
is projectile motion difficult?
No, sir.
Okay, thank you. Okay, so we need to get an equation for the maximum height. So we saw that h is u sine theta t minus half gt squared. This is the equation we can use to calculate the vertical height or vertical displacement at any time. we can also do that using v squared is equal to u sine theta squared minus 2jh. So if you make this h the subject, you get an equation which will help you determine h at every velocity. Now, at the maximum height, the vertical velocity Vy is 0. So if Vy is equal to 0, then it means we are at the maximum height. Substitute 0 for V, and then help me make h the subject. Substitute 0 for this V, and help me make h the subject. Let me call somebody else to answer. Ernest Forsen. Ernest, are you there? Ernest, are you there? Okay, Mamiya wants to answer. Mamiya, go ahead. Atampo. Hey, Atampo, your hand was raised earlier. Bridget, go.
Say h equals u sine theta over 2g.
Exactly. Hey, Bridget, come again. Oh.
H equals u sine theta over 2g.
Sorry to disappoint you. Bridget, look at it again. There's Achampo. Go ahead. Achampo.
Sir, please. H equals u sine theta squared over 2g.
Exactly. So, Bridget, you omitted a square. U sine theta all squared over 2g. Do you know what this means? This is an equation to help you calculate the maximum height reached. The maximum height reached. So the same question. Help me calculate the maximum height the projectile can reach. Help me calculate the maximum height the projectile can reach.
$25 meters.
Are you sure?
Yes, sir.
Look at it again. Okay.
So 125 meters.
Come again.
125 meters.
Okay. More views. Let's see. More views. Bagwaji.
Sir, please. 125 meters.
And let's see. Let's calculate and see.
Sir, please 12.5.
12.5. Okay, let's
Yes,
see.
sir.
So we have maximum height. This is equal to 100 sine 30 into bracket squared. There's a square divided by 2 times acceleration due to gravity. 20. H max is therefore sine 30 is half. Half times 150. So 50 squared divided by 20. And 50 squared is 2500, isn't it?
Yes, sir.
Yes, sir.
So, 250 divided by 2. $125. So those of you who called 125, you can be smiling. So that's the maximum height reached by the projectile. Okay. So we've discussed vertically the displacement. The displacement is h sine theta t minus half gt squared. We've discussed the velocity. The body accelerates when going up due to gravity, decelerates when going up, and then would accelerate when it is falling. So we've discussed the velocity, the displacement, and then the acceleration. So we've done that for both vertical and horizontal. And one last thing, please note that at every time t, there are two velocities, a constant horizontal one and then the vertical one, which changes due to gravity. So when there is a question of the resultant velocity, the resultant velocity must be for both the horizontal and then the vertical. So if we have two velocities, one is acting in this direction, another is acting here, then the resultant will act along the diagonal. So when the body, let me draw something to explain this part a little bit. If this is the trajectory or the path, over here when it is going up, there is a horizontal one here, there's a vertical one here. So the resultant will act along the diagonal. And you can use Pythagoras theorem, equal vectors. What is here will be the same as here. The horizontal is perpendicular to the horizontal, the vertical. Okay. So the resultant, which will be the diagonal vector, will represent the horizontal. And you can use Pythagoras theorem, and we saw this too in one dimension. So v squared would actually be equal to the constant ux plus the vertical vy squared. This v therefore will be equal to the square root of the constant squared plus the vertical squared. And you know the constant, the horizontal one is u cos theta. And then the vertical one is u sine theta minus gt. That depends on the time. So, example, determine the velocity, the same question. Determine the resultant velocity after 2 seconds. Class, that's your question. You are going to work that out now. Determine the resultant velocity after 2 seconds. Start work. Let's see how you can handle this. Then we discuss it, and then I'll send you example to solve, okay, for tomorrow. So determine the resultant velocity after 2 seconds. And note that after 2 seconds, the body has not reached the maximum height. So know how you would handle this. So 3 minutes. I'll get back to you. is due. Give me your answers. The velocity, the resultant velocity after 2 seconds. What are your answers? Who will start? Who will start sharing what he or she has? Farida, are you the one to start? Or Bridget? Or Francis? Hmm? You people are not talking. No. Are you there? Francis, Bridget, Farida, and the rest of you? Prince, Lionel, Alvin. Hey, your quietness, is it an indication that you couldn't answer the question or what? Francis,
Yes, sir.
what's your answer?
Sir, please add the 2 seconds, was it the maximum height?
No, hey, you see, the time taken to reach the maximum height is 5 seconds. So it means
Oh,
at a time of 2 seconds, it hasn't gotten to the maximum height yet.
oh, I
Okay,
use that instead.
okay. So at 2 seconds, because it is not at the maximum height, it means there will be two different aspects of velocities. The constant horizontal one, which is 100 cos 30, and this is 86.6 meter per second. And then the vertical one, which depends on time, u sine theta minus gt. At 2 seconds, it's not at the maximum height yet. So this is 100 sine 30 minus 10 times 2. So 50 minus 20, giving us 30 meter per second. What it means is that at 2 seconds, supposing this is the position 2 seconds, there will be this velocity 86.6, and then a vertical one which is 30. So if you want the resultant velocity, then you should use Pythagoras theorem to find the resultant velocity, and that will be v. Okay, so using Pythagoras theorem, v squared would be equal to ux squared plus the v squared, and we found ux. Ux is 86, so 86 squared, 86.6 squared plus 30 squared. V would be equal to the square root of this. So quickly calculate that for me. What's the square root of 86.6 squared plus 30 squared? Can somebody quickly calculate that for me? Barry,
91.64.
come again.
91.649.
5 meter. So this is the resultant velocity after 2 seconds. The resultant velocity acting on the body after 2 seconds. Class, are we okay? All right. So if you are okay, it is exactly 3:15. I'll send you about 2 examples, simple examples to try, okay, so that we can master this very well. All right. So this is where we'll end today's show. If you don't have any questions, we'll end here and we'll continue next week. May the good Lord be with you. Take care of yourselves and bye-bye. Of course, I'll share the video, okay? I'll share the video. Okay, bye-bye.